Okay, today is July 24th, 2020. And right now we're looking at this is the long wave IR map. We're looking at Hannah, which has strengthened slightly. If you look at the National Hurricane Center map, we can see that Hannah has strengthened slightly. We've got 65-mile-per-hour winds. The pressure is down at 992 millibar. That's down from about 1,000 or so, 1,000 millibar earlier, yesterday, and then through this morning. So it's now moving west at 8 miles per hour. So it looks like it may hit the Corpus Christi area. If we look at the Doppler radar map, we can see Corpus Christi right dead ahead. And notice this odd shape here. We've got a lot of satellite transmitter activity going on with this storm. If we look at this is the long wave IR map, we can see that as this storm develops, we see blast patterns right here. For example, this is a satellite transmitter superheating this area. But it's all about the power, and I've mentioned before, the weather controllers could squash these out at nothing flat, and but that's not happening. So we're seeing a show. We're seeing the blast patterns and all that, but this is going to apparently be allowed to run into Texas and cause some flooding. We have the technology to destroy and prevent hurricanes. We also have the technology to steer hurricanes into targets if we want to do that. All right, so let's take a look at the water vapor map here for this storm. And we see some odd evaporation patterns here on the northwest side, which we see here better actually in the long wave IR map. We see the blast pattern here. So this is being targeted. It's a show, but they're not applying, the weather controllers are not applying enough power to completely disrupt the convection in this vortex. Now we see a little bit of rotation, but it's not very well organized. So nonetheless, this can drift onshore and dump a whole lot of rain. This could be just as damaging as a Category 2 hurricane in terms of flooding. And this is moving rather slowly. If we go back to the Hurricane Center map, we can see that this is moving along at 8 miles per hour. So once this reaches Texas, the shoreline, this can be stalled in place. And we've seen that before. We've seen hurricanes that were stalled in place for several days here in Texas that dumped about 30 to 33, 34 inches of rain in 2 days, which is a record. Remember the Gulf of Houston was pictured, they called it the Gulf of Houston on the Dredge Report, which, by the way, the Dredge Report has been commandeered, co-opted by the mainstream media combine. The Dredge Report is just a garbage website now. It's like reading CNN or MSNBC. There's no point in looking at the Dredge Report. It's completely mainstream media trash. So there it is. But nonetheless, we have Hannah, and this storm is just creeping along at 8 miles per hour. So we're going to keep an eye on that storm as well as these other ones. We have Gonzalo. I think it is. Let's go back here. Gonzalo. This storm has weakened slightly with 40 mile per hour winds. It's still moving west at 17 miles per hour. The central pressure is 1,009 millibar, but this is expected to strengthen as it moves into the Caribbean Sea area right around here. So we'll keep an eye on that. Going to the Eastern Pacific, or rather the Central Pacific. Let's get the Central Pacific pulled up because that's really where this Hurricane Douglas is now located. And we can see Douglas is just getting very close to reaching the Hawaiian Island area. So this storm now is 115 mile per hour winds, sustained winds with a central pressure of 967 millibar, moving fairly quickly at 20 miles per hour to the west-northwest. And the trek is slightly modified. Let's go ahead and look at the cone trek, and it's showing that now it's moving in a slightly more northerly trek right over the probably Oahu area and over Kauai on Sunday afternoon. So we'll have to keep a close eye on that. Let's take a look at Hurricane Douglas, which is sort of being pushed. We can see some high pressure right here where this dark area is. We don't see a uniform bands of moisture all the way around this storm. If we take a look here at the let me fix the contrast on this thing. There we go. So we see high pressure installed along this area. You can see the uniformity of the water vapor around this storm is rather not uniform. It's if we look at the water vapor map, we see the same thing. Let me pull the contrast down again. And we can see the eye wall of this thing is being disrupted. It's been hit a few times. This storm has been targeted several times by satellite transmitters. We see the blast patterns. But once again, it's all about the RF power applied, or the laser power in watts by these satellites, and that will determine how much power is applied and how much disruption we have in the vortex of that weather system. All right, so we can see that eye wall is undulating. It's not too well organized. It's actually reorganizing. We can see the blast pattern, these icicle patterns around the edge of that storm as it moves towards the Hawaiian Islands. Wish this camera would stay where I put it. I can't get the contrast to stay where I want it. Okay, so looking at the long wave IR, we can see that high pressure installed on the south side of this storm, and that's going to push it to the north. We can also see the straight edges around those rain bands. Look at that. Look at the evaporation pattern on the south side of this storm. So this storm is being nudged to the north, and we can see that very clearly in this 200 frame sequence. There should be a uniformity of water vapor all the way around this weather system, particularly as we approach the vortex. Look at the evaporation right there. We see a sort of a flat spot develop right there. So we're going to keep an eye on that and see what happens. But as I've mentioned, the weather controllers have complete control over our weather. This is a show we're seeing here. This is a show. They're going to steer this close to the islands, and probably at the last few hours they'll hit it with some power and knock it down to a tropical storm. And we'll keep an eye on the Doppler radar map. Here's once again is Hannah right off the Corpus Christi coast of Texas. If we zoom out and go over towards the Hawaiian Islands, we can take a quick look out there and see what's going on. So everything looks pretty good out there towards the Hawaiian Islands so far. We see a little bit of precipitation near Oahu up here, and then we have the Big Island. We have a little bit of rain near Hilo, but nothing yet from that hurricane, it looks like. All right, in the meantime, we'll keep an eye on Hannah and see what those WSR88Ds are good for. If anything, we should see those be kicking in pretty soon to protect the valuable property along the Texas coastline here. So we're seeing a very wide barrier of clean air, or rather a lack of precipitation in this area between the coast and the storm itself. So as this moves towards the coast, we're going to keep a close eye and see what happens. Let me get the contrast up there. There we go. Let's go back out to Hawaii. I don't know if that contrast was showing up. The picture was showing up very well with that contrast setting that I just had for the water vapor map. Okay, so the Hawaiian Islands, we can see there's not too much activity in terms of precipitation. Keep an eye on that. Moving back over to the continental U.S., you can see a little bit of severe weather over Nebraska, South Dakota, and North Dakota. See if we can see any WSR88D activity. No, we don't see anything. No pie-shaped cutouts. Okay. All right. Next, we have the GOES 17. This is the Channel 13 infrared map. And we see Douglas approaching the Hawaiian Islands. This is a 200 frame loop as well. We can see that it's targeted. And the eye wall disappears momentarily and then reforms. You see that flat spot along the southwestern side of the storm. Depending on where the high pressure is installed near the vortex, they can steer this thing or slow it down. Or they can stall it completely into place. Put high pressure on one side, on the other side, and just hold it right in place. And let it sit right over any city they want. Let it dump rain once it moves inland. Just because it moves inland doesn't mean it's not a dangerous storm. It can still dump a lot of rain. Okay, so that's going to be the pretty much the end of the report. We'll keep an eye on this system out here, Hurricane Douglas, which is now a Category 2 storm, I believe. Still, well, it was a Category 4, and it looks like it's up at Category 2 status with 115 mile-per-hour winds. Okay. All right, so we'll keep an eye on everything, and we'll just call it a day, and we'll do another update probably tomorrow. Okay, that's it.